Alright, this is 5.1 problem number 4, which is kind of tricky and confusing because it's bringing in some principles of physics that aren't really explained well in a math course. So, what I'd like to talk about is what this chart they gave us represents. So, I probably should have written down the chart beforehand, but the chart has time in seconds, and then it has velocity in centimeters per second. And so we've got this chart, and it includes 10 seconds. So 1 second, 2, 3, 4, 5, 6, 7, 8, 9, and 10 seconds. And then it gives us a velocity for every second. At second 1, velocity is 0 centimeters per second. At 2 seconds, it's 5 centimeters per second. At 3, at 0, it's 0. They start at 0. I'm sorry. Okay, so in seconds, we have second 0 all the way up through 10. So at second 0, we have 0 centimeters per second. At second 1, we have 5. Then it goes on to say 11, 18, 24, 36, and then the person starts to slow down, goes back to 24. Then 15, 8, and 4, 15, 8, 4, and at second 10, they're back to 0. Alright, so I'm going to put up kind of dividers so that way we don't get our numbers mixed. So this is the chart that we're going to be using. Now I want to prove that the area under a graph such as this is actually equal to the displacement, or the distance traveled. And how I'm going to do that is proving that finding the area of this cancels certain units. So let's say that we're looking at a square, which a rectangle. All of these are a rectangle. And on one side of the graph, the y-axis, we have units of centimeters per second. Okay, so the units of this long side, the y-axis, are centimeters per second. And the base is seconds. Now we know that a rectangle is equal to length times width. So if the length is centimeters per second and the width is seconds, you'll notice that the seconds cancel and we're left with centimeters. So the area inside of this rectangle represents distance, or displacement. And so when we add up all of these approximations, we're going to figure out how far this person roughly traveled. And so how do we do that? Well, first we need to figure out what's our equal width of every rectangle. And we'll notice that each interval is 1 second. So delta x, we'll call it, is 1, because in the x direction, the width of each rectangle is 1. Now, if you remember, to add up all of these rectangles, we're going to take delta x times the height of the first rectangle times the height of the second rectangle times the height of the third rectangle. But because all of these rectangles are being times by delta x, we can actually factor delta x out of every term, because every one of these rectangles will be multiplied by height and delta x, height and delta x, height and delta x, height and delta x. And the heights change, but the delta x stays the same, so we can factor that out of every one. And now the question asks the distance traveled using 10 subintervals of length 1 second with left endpoint values. So what the left endpoint values are is what I have drawn up here. So in other words, 0 goes with 0, and the left endpoint of that is over here. 1 goes with 5, and so when we're at 1, we're at 5. So instead of choosing what it is when we're at 2, we're choosing what it is when we're at 5. So at 2, we're at 11. So that means that the height of this third rectangle is 11. And so in order to do that, we'll take f of 0, which is the height of the first rectangle, plus f of 1, which is the height of the second rectangle, plus f of 2, height of the third rectangle, f of 3, height of the fourth, f of 4, height of the fifth rectangle. So you can look here, 4, is this high, and that's our fifth rectangle that we're filling in there. Then we're going to add f of 5 for the height of our sixth rectangle, f of 6 for the height of our seventh rectangle, f of 7 for the height of our eighth rectangle, f of 8 for the height of our ninth, and plus f of 9 for the height of our 10. And that's where our 10 rectangles end. So this is using left endpoint. So we know we can fill in delta x is just equal to 1, f of 0 is 0, f of 1 is 5, f of 2 is 11, f of 3 is 18, f of 4 is 24, f of 5 is 36, f of 6 is 24, f of 7 is 15, f of 8 is 8, f of 9 is 4, and we're not counting f of 0 because that would be a right endpoint. So now we add all these up, and we'll end up with 5 plus 11 plus 18 plus 24 plus 36 plus 24 plus 15 plus 8 plus 4 times 1 tells us that the approximate distance that we traveled, estimating using left endpoints, the estimated distance is 145 centimeters. And then the next question is asking us with the right endpoint. So we did the left endpoint, which means that the left point of the rectangle shows how tall the rectangle was. But what if we choose the right endpoint? What does that look like? So now the height of the rectangle, the first rectangle, will be the height of its rightmost endpoint. And so that would mean this rectangle is this tall. And this rectangle is this tall. This rectangle is this tall. This rectangle is that tall. This rectangle is this tall. And hopefully you're getting a feeling for it as to what this looks like. You'll notice that early on the right endpoint was overestimating, but later down the line it's actually underestimating. And so now we're going to figure out what it would be with the right endpoint. And so to do that, now that we know how to do it, I'm not going to write every step down. We know that we're going to take delta x times the height of every rectangle that we have. Well, our first rectangle is now height 5, right? Our second rectangle is height 11. Then so on, 18, 24, 36, 24, 15, 8, 4, and finally we are including 0 now, because 0 is our 10th rectangle height, as you can see over here. And when we add these up, we'll find that we get the same answer as when we use the left endpoint. We also end up with, oh, whoops, I must have done this wrong. 5 plus 11 plus 18 plus 24 plus 36 plus 24 plus 15 plus 8 plus 4. Yep, so we end up with 145, and of course delta x is still 1. So distance equals 145 centimeters with the right endpoint. And the reason why this isn't the case for every approximation. The only reason why it didn't matter if we chose right or left endpoint for this problem is because it starts at 0, right? So if we start with the left endpoint, we start at 0, and then we include all of these numbers. Well, if it starts with the right endpoint, we end with 0, but we include the 0 over here. So it doesn't really matter because zeros aren't going to create any difference in quantity. So because the left and right endpoints include 0, it didn't actually make a difference what endpoint we chose. But yeah, hopefully this was helpful, and I'll see you next video.